Hi there, my name is Neil Deshmukh. I'm a junior in high school. We currently live in a period of time where scientific revolutions are happening all around us, right? Almost every day, we hear about a new discovery that, promises to change the world or make our lives a little bit better. Unfortunately, though, many of the strides in the field of science, particularly in technology, don't focus on helping the people that really need help. So I realized this firsthand in the summer of 2016, which is the summer before my first year in high school. I went to India, which my family does every year. It's really nice, meet with relatives, my grandparents, cousins, and get a sense of life there. This trip was a bit different, though. It was a change in my point of view, in the way I saw the problems faced by people there, specifically my family. So it all started because my uncle and my grandpa, they invited me to visit the farm that they worked on in order to get a better sense of how life was for them. The first thing I noticed was how intensive the work was, the long hours they had to labor under the hot sun. My uncle was fairly healthy, and even he was having trouble. Well, I couldn't even last an hour there. Well, I couldn't even last a day there, right? Just working in the fields. I met a few workers who had skin conditions like scabies. I was astonished that they could fight through doing such laborious work in such intense environments, especially with the burden of skin diseases. My grandpa told me that they had to work to support their families. He told me that there were many others who had common symptoms but couldn't figure out their disease, and those who had heart issues but didn't recognize the severity before it was too late. Getting the treatment wasn't the main problem here. Treatments for many such conditions were in a local town, but many villagers were not willing to make the journey to the nearest doctor to get diagnosed, and could not, on top of that, afford a trip to the doctor. I knew almost immediately that this was the problem that I wanted to try to address. People close to my family were going through life with these conditions, ones that could be treated, and they made their lives, difficult. So once I got back, I started looking into ways that I could somehow solve this first problem, which was skin disease. 2016 was the year where, the field of deep learning and AI were really exploding. And I started to read articles and then research papers describing about how there were, these new algorithm structures that were getting better and better at classifying objects. I began to think, what if instead of trying to classify everyday objects, I develop and train my own convolutional neural network, or CNN, to identify skin conditions? So I did. I scraped data sets, pre-processed them, iterated and tested different network architectures, and what I realized was CNNs are a pretty amazing tool, because instead of, preemptively programming specific features to look for in an image into my algorithm took in raw pixel values, and it itself discovered custom feature identifiers to learn to classify objects all by itself. So the biggest hurdle for this project was in its implementation, because I wanted to make a solution that would allow users to identify their skin disease in real time. So in this case, I chose to make an app. All you had to do was point your camera at the disease, and it would classify it. With this part of the project, I managed to make it to the Intel International Science and Engineering Fair, where I got a second grand award. The entire process was inspiring, meeting with like-minded kids and mentors who provided valuable insights into my project. So the next year, I chose to delve deeper with my project. This time I chose to target the problem of symptom analysis, which was trying to identify potential conditions from the symptoms. Actually, a funny story was when I told my friends about the problem I was trying to solve, they immediately brought up WebMD and jokingly began to make fun of some of its terrible suggestions. Getting back on track though, for my project at least, I decided to use a deep neural network algorithm in order to automatically provide possible conditions from symptoms. Neural networks in general are based on a a hierarchy of complexity, because early layers, they compute simple correlations between the inputs, right? And then you have more advanced connections as you progress through the layers. This lets DNNs to be really effective at determining complex correlations between inputs, which is perfect for symptom analysis because each symptom is not isolated, right? Sometimes they kind of meld into each other. The body is, interconnecting parts, and because of that, there are complex connections between symptoms. Then I targeted the problem of myocardial anomalies, specifically myocardial ischemia and arrhythmias. I chose to use an RNN, which is exceptionally good at determining patterns in time series data. And by using a bidirectional LSTM, it allowed the model to further figure out context within the ECG values. I had to use what's called a many-to-one approach, because you have many ECG values and one output, which is ischemia, arrhythmia, or normal. Again, for both algorithms, I scraped data, developed an algorithm architecture, iterated and tested to optimize the algorithm. The process I aimed to solve further was the accessibility of the device. So it'd be a low cost, run offline, but be accurate as well. I achieved this with the Raspberry Pi based design. Again, the biggest problem here wasn't in terms of developing the algorithms, but instead optimizing them to run on this low memory processor. So if you want to know more specifics, the techniques are in my other documents, but the main breakthrough for my project came with the use of memory mapping. The idea here was to take the algorithms and buffer them at specific intervals, and then you load the specific sections into the memory and parse the inputs and outputs. Essentially, instead of loading the entire model into memory at once, you load sections. In the end, I presented my research at multiple conferences, like the MIT Undergraduate Research Technology Conference and the IEEE Ubiquitous Communications and Computer Conference, where my project was awarded as the best machine learning paper. The thing that I really love about AI technology is its ability to quantize intelligence. In this case, I can take the knowledge about different kinds of medical analysis, for example, turn it into a series of ones and zeros, download it onto a $55 device, and ship that intelligence anywhere in the world. And to me, that's pretty amazing, right? Because it allows us to do things it allows us to help people in ways that we could never have thought of in the past. For example, creating a device to automatically conduct medical analysis. The skin detection CNN was actually built on the experience I gained from developing a solution to allow farmers, like the ones I met, to diagnose their own crop diseases. I've also published an app on the App Store called Vocalize that uses AI to help visually impaired users navigate their environment. So if you want to know more about my other projects, those are included in the supplementary documents. My algorithms prove the capability of deep learning to be used as a tool in medical review because, as shown, these algorithms are able to automatically extract relevant features from the biometric data in order to perform the accurate analysis that's necessary for the device. The uses of this technology are almost endless. They're just limited by our creativity. With every piece of work that I do on this project, I learn more and more about the AI space, and it has allowed me to work on state-of-the-art algorithms and techniques. I've grown as a developer, and more importantly, I've learned the human side of coding, developing solutions to solve the problems of the people themselves. The thing that I've realized over the course of this project is that to solve a problem, you have to make sure the solution is accessible. It doesn't matter how good the solution is if the people that need it can't even get access to it. Then it's just useless to them. I've dedicated the last 3 years of my life to this device. And to be honest, I really don't see myself stopping work on this project. There's so much more to add. Oh yeah, and by the way, the entire software and hardware design for the device is completely open source. So people can just, add to it and do whatever they want to increase its usability and make it even better. Even for all the work I'm doing for the project, I'm still one kid, And my hope is that in the future, people from across the world will pool their resources, their work, into this device so that it will become better and better than it is now. I don't just want to end by creating some algorithms, a basic implementation, and just leave the project, say I'm done, or just pass some benchmarks. Technology is like a superpower for us. It lets us change the world from thousands of miles away. If people believe that cars will soon drive us automatically, what's stopping the technology from at least providing basic medical analysis to help make the healthcare system more efficient? What I really want to do is to develop and implement an actual solution, something people in the future can hold, something they can use to analyze, to treat their medical condition automatically within their own home. That's my overall dream, to create solutions to help people less fortunate than us, to build a future where you won't be able to tell places apart just based on the condition of their living. To create a world where everyone can live the same stable lives that we do without suffering from easily treatable diseases. Thank you for listening to me talk about my project.